All right, first HSC topic. I call it geometrical applications of calculus or of differentiation. Your teachers might just call it applications of differentiation, or they might just call it max-min problems or whatever. But the idea is it's actually the applications of calculus geometrically. So graphically as well as in terms of shapes. Good news, it is worth about 10 to 15 marks, this whole topic in your HSC, because now everything's going to count. So 10 to 15 marks. The first 8 to 10 marks of that are easy. The last 10 to 15, which are based off what we say max-min problems, are hard. I'm not going to rush through that. We might take 4 weeks, 5 weeks on that, which is just one exercise. One exercise, not one chapter, one exercise I'm going to take 4 to 5 weeks on. Cool? Hi. So I do that on purpose. It's not easy. It is a band 6 style question, those max-min problems, okay? So when I say we're starting max-min problems, you got to really put your thinking caps on. I'm just going to close the door and get started. And please talk. If there's something that's confusing, if I'm going fast, talk. All right. Increasing, decreasing, and stationary points. A function is said to be increasing if the tangent has a positive gradient and the y values are increasing as the x values are increasing. That's a really fancy way of saying if your graph is like that, if it's shaped to the right, it's obviously increasing. The gradients are all positive. Make sense? A function is said to be decreasing if it has negative gradient. Again, that's just another fancy way of saying if something was shaped that way, then these are decreasing gradients. Yep, slope to the left. A function is said to be stationary, which means it's not increasing nor decreasing, if the tangent has a gradient of 0. If the tangent has a gradient of 0, when did we have gradient equal to 0? When we had a flat line, right? When your line is flat, there's no gradient, the slope is 0. So in other words, right there. Your turning points are called stationary points. We don't call them turning points anymore because turning points are usually used for parabolas. Stationary points are used for every curve. But they're the same thing. So stationary, and again, you can see here that the slope is decreasing. Here, the slope is increasing. And what about here? It's stationary. It's not increasing nor decreasing. Sounds good? At this point, any questions? All right, here we've got y dash, because it's negative, y dash is going to be less than 0, right? The gradient has to be less than 0. Y dash is the gradient function. Say it. Gradient function, okay? You've got to understand that. So it's not the gradient, but it allows you to find the gradient. And if the gradient function is already less than 0, then that means the gradient must be negative as well. And then same thing here, y dash is greater than 0. Positive gradient. And then obviously when it's stationary, y dash is equal to 0. Happy with that? Decreasing, y dash less than 0. Increasing, y dash greater than 0. Stationary, y dash equals 0. And we move on. On the following graphs, indicate where the function is increasing, decreasing, or stationary. All right, here we go. Starting from the left. Tiana, what do you reckon? Increasing. Just draw these positives and negatives, yeah? Positive, positive, and then here, flat, so 0, negative, 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 flat, 0, positive, 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 positive. You can see it's changing like from a, this is sad, 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 stop. Happy starts, happy, 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 happy. And we will talk about those stops at the end. Happy, 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 happy. Maybe sad, 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 sad. Happy, 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 happy. But the slope is still positive. We see that? So it's still concave to the, I mean, it's still pointing to the right. Cool. Josh, if you've got questions, you know the drill, just let us know through the chat. I can't see it straight away, but I'm sure these guys will let me know. B, again, I think pretty easy. Positive, 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 flat, negative, 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 flat, positive, 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 flat, negative, 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 negative. Happy? You're happy, I'm happy. Yep. Done. Move. What's the key word when you're reading that? Nope.
Increasing.
Done. That tells you? Yes, and then increasing specifically means y, like that. That's what you need to link straight away. When you see tangents, you think of y dash, right? Same thing with this. Increasing, y dash greater than 0. It says, show that this is increasing for everything, for all values of x. You see how you just wrote that? It's what you've got to always do when you're studying. Good work. All right, here we go. Y dash equals 5, and therefore? Oh, no, you don't need to get to that point yet. Therefore, just greater than 0. Take it easy. Firstly, what graph is it? Let's make sure you know what kind of graph it is. Straight line. If you think of a straight line that has positive gradient, well, wouldn't you say it's always right? Wouldn't you say the slope is always increasing? You know that. Got nothing to do with this topic. But now we're just trying to show it through a different way, through derivatives, calculus. It says show that it's always increasing for anything. All right, y dash equals 5. Well, 5 is always greater than 0. Always greater than 0. Therefore, always increasing. Easy? Seriously, yes? Yeah. Done. Show that y equals x. 100% will be in your exams. I think you guys know what that means. That means you've got to know how to show something is increasing or decreasing. Right. Show that y equals x cubed is increasing for all values of x, apart from x equals 0, where it is stationary. All right, very good. So, y dash equals 3x squared. Correct. So I like that. So this is technically always greater than 0. Always greater than 0 for every number except what? Except at x equals 0, where you get y dash equals to 3 times 0, which is 0. And what happens when y dash equals 0? Done, done, done. I think we're getting this. Stationary. Please do not go to school and tell me my teacher did it this way, I got confused. Don't do that anymore. We're in year 12 now. No more. You guys are getting it. Keep it up that. Any questions? No? Again, reread the question maybe. Just reread it. Show that y equals x cubed is increasing for all x apart from 0 where it is stationary. Well, think about it. Y dash is 3x squared. Tiani said no matter what x I sub in, it's actually always positive. You're right. Except where x is 0, where you will get y dash is stationary. Good point to make. It is a cubic. Let's have a look at a cubic. It looks like that. Sorry?
Sorry, I started with the next question.
Oh, no, that's okay. That's a cubic. And you can see right there something's happening. It moved from a sad to a happy. And we're going to talk about that in our points of inflections. Let's do the next one. For what value of x is this increasing? All right, I think you guys know what we're going to do. When you see, what's the key word, Lissandro?
Increasing.
Increasing tells you
Y greater than 0. Y dash greater than 0.
y dash greater than 0. So therefore, f dash x equals 3x squared minus 6x minus 9 greater than 0. And then I think the way we always did inequalities was I left them as equalities and then we just tested. You guys still okay with that? I can see I can divide it 3 out, so I might as well do that just to make it easier for myself. And then I get x minus 3, x plus 1, x equals 3, x equals negative 1, stop and draw on a number line. There's negative 1, there's positive 3, open circle, test, x equals 0, which is right here, into this one, into f dash. What happens when you sub in 0 into f dash? You'll get negative 9, which is greater. Is negative 9 bigger than 0? You would say no, it's not, which means this doesn't work. Therefore, your answer is x is less than negative 1, x is bigger than 3. Are we fully confident with that by now? That's great. All right, done. We'll get to these. It's not a big issue of mine right now. I'll get to them. Oh, how good's that? Let's have a look at a HSC question. Actually, this is what I'll do. Go back. I'll write homework as well. Leave that as your homework. Or if you stay back or whatever, that can be your classwork. Let's just leave it like that. There you go. All right. HSC question. The diagram shows the graph of a function, y equals f of x. For which values of x is the derivative f dash of x negative? So for which values of this is the derivative negative? Well, positive, 0, negative here. So negative, 0, positive. All right, so for which values of x? How would you write that? Now that you know it's between what and what? So how would you write that?
Negative 1 less than or not equal to x.
If you say equal to, it's a stationary point at negative 1. It's a stationary point at 3. You can't say they're equal to. It's just any number between negative 1 and 3. Good work. I told you he told us to do better. Double I. What happens to the derivative for large values of x? What happens to f dash for large values of x? Okay, I didn't realize this was coming up so soon. That's okay. It's not what we have covered exactly yet. So let me just see, scroll down. Let's go back. And
Question for the first one.
yes.
You know, it says describe the function y equals x.
Yes, this is y equals fx.
Yeah, the question asks for derivative f dash.
Yeah, for which values is y dash less than 0? So when y dash is less than 0 is when the slope of your what is deep here.
Okay.
Yep. All right. So now, let me see if it's in here. Hold on, you guys. Because I know what you need. I don't know why that's so soon. It's right there, right? It looks like it's there. Analyzing curves. Yeah, so why did you put it so soon? Okay, we'll just keep going. Keep going. Yep, all right. We'll need something before. Yeah, that's fine. We'll need to know something before we do this, and I'm actually happy to say it now because I'll probably have to say it a few times. So just maybe the back of your booklet. Is there any paper? No? Then just keep it on there. Keep it on there, it's okay. No, I think in spare paper. If you've got spare paper, if you've got spare paper. Write this heading. How to draw derivative graphs. Derivative graphs. And then we'll staple it. It's under its down as well.
Let's take one.
Take one. All right. Josh, how to draw derivative graphs. Is Eden here now as well? Oh, yes. Oh, everyone's here. Chen, Rad, hi. How long have you guys been here? Hi. You've heard everything so far?
Yeah.
Good.
Hey, Tim.
Hi.
Yep.
Hi. All right. We'll talk about the classwork and homework soon. And we'll see if you guys can maybe even come face to face as well. We'll talk about that at the end. All right. Heading on exclusive of that booklet. How to draw derivative graphs. You'll see this in your homework, but I'm going to teach it to you now, so at least you'll be able to do it for your homework as well. All right. How to draw derivative graphs. I do it differently to your teachers. You've obviously heard me say that 1,000 times. So this won't be a technique you'll probably see at school. Here we go. You're going to remember this. ISP. ISP. I, intercepts. S, stationary points. P, point of inflection. Intercepts, stationary points, points of inflections. ISP. If we are differentiating, which we are, we're going to read this upwards. So differentiating, y dash, we read it up. For next year, we're going to be doing integration, which is why I teach this method. We're going to do it this way. We're going to go down when we integrate. Integration is opposite of differentiation. So that's why we're going to go down. Okay, so one more time. If we're trying to draw derivative graphs, our points of inflections, which I'll explain in a sec, become stationary. Our stationary points become intercepts. We understand how to read that? Anyone confused? Okay. So let's just say I've got this graph, which we are going to call y equals f of x. Obviously, what graph is this? Parabola. What happens when you differentiate a parabola? What do you end up getting? A straight line. We agree with that? Let's see. This is the way these work. Points of inflections. We don't have any, but I'll explain that when we do have. You'll see it. We're going to draw y equals f dash of x. Okay. Stationary points. We do have a stationary point. A stationary point somewhere here. Yes? That stationary point becomes... Still frozen? For you as well? What's happened? For you guys at home, is my screen frozen?
I don't think so.
Hasn't frozen for me. Oh, maybe our internet. Still? Let me pick back up and see what else is running. Nothing else. Everybody else that's online. You might need to maybe, yeah, try that. See if that works. Yep, you're back.
Yep.
Okay, so stationary points become intercepts. So, and that's good because you specifically know the y value of an intercept. It is 0. It's an x-intercept, right? So that is going to be here. I won't do it at the origin, just for argument's sake, but we'll just do it there. Cool? We're okay with that so far? And then, if you guys remember this from when we did graphing in polynomials, I said if you start at the top left, we start at the bottom left. And that's why I teach like that, because everything's going to start overlapping. Boom. You start down here, you've got one turning intercept only, you cut through it, look, it became a line. That was easy. Any questions? Let's try that again. With something like this. Okay. I'll put numbers in this time, just to -3, -2, -1, 1, 2, 3. Okay. What's the acronym? ISP. Intercepts, start points, points of inflections. If we're going to go up, it is differentiating. If you go down, it's integrating. True? So points of inflections become stationary, stationary become intercepts. Let's have a look at this. Okay. And intercepts become nothing. So you don't look at what intercepts become. Well, so all you're interested in is P and S. That's an S, that's a P, and that's an S. So a point of inflection is just the point where it's changing from a maximum to a minimum, or a happy to a sad, or a sad to a happy. Correct. So that is your point of inflection. Anyone at home not understand that? Point of inflection. No, we're good. All right. So let's start with our S's. Stationary point becomes a intercept, and that's beautiful because right there, stationary point becomes intercept right there. Point of inflection becomes stationary. Now, you don't know the y value. You don't know if that's going to be like this, right? Sad like this, up here, or if it's going to be happy like this. You don't know. You don't know. Understood? All right. But what we do know is that it is stationary. So what I usually draw is that or that. And then we're done. We're just going to start at top left. Why? Because this graph is starting bottom left. So start at top left and look what happens. I'm going to use this guy. Look, start here, cut through, cut through, cut through, bounce, 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 cut through. Done. And it actually makes a lot of sense. Think about it. I just drew the derivative, right? And isn't the derivative meant to have one less turning point than your original because you're differentiating? The original had 3 roots, 1, 2, 3. Your derivative will have only 2 roots, 1, 2, 1. Easy? Seriously? Done? 100%? Very good. Again, anyone have any problems? I'm going to show you the hardest question you'll get, and that's it. The hardest one you can get is what's called a horizontal point of inflection. So the ones that look like the cubics. So those horizontal point of inflection. So this is a point of inflection. We're going to do a horizontal point of inflection. Those squiggly ones. Squiggly is horizontal. Yeah, it's good. Have a good laugh at it. Yeah, at least remember it. All right. Let's do this. Don't come up to me in your exams and say, Sam, I got a horizontal point of inflection. I got it wrong. I just did it. I told you to do it. All right, here we go. Let's go horizontal point of inflection. And you know what? I'm even going to do an asymptote at the same time. Because if you guys seem to understand this, then we won't have any problems.
Is that a bump in like the first part?
So let's talk about that. This is going up, 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 up. Sorry, this is meant to be a, your squiggly. Then going up, 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 and then turning point coming down, and then another bump to make this obviously not cut through the asymptote. Yep. Okay, this is y equals f of x. Before we start, we write the ISP. We're going up right now for this year. Now, this is what you've got a note that you've got to write. Horizontal point of inflections. So these guys here, that's a horizontal point of inflection. That's not just a horizontal, that's not just a point of inflection, it's a horizontal point of inflection. These ones here don't just become stationary, but they become stationary and intercepts. Why? Because it is stationary here as well. So y dash equals to 0. Didn't we just prove that for cubic? Wasn't that what we just did? We said it's actually increasing everywhere except at 0. So horizontal point of inflections become stationary and intercepts. Stationary and intercepts. That's it. That's the only one you got to remember. Get it. There we go. All right, here we go. So let's start with our stationary ones. It's stationary there. So that's stationary. That's an intercept. Again, we'll just do it here, just so we're not exactly on the line. There we go. Sad. And then something needed to happen here to make this look like it's about to become a happy, right? So what's this called? That's actually a point of inflection. I can say 9 out of 10 students missed that one. But that's a point of inflection. Otherwise, it would have just been sad all the way, right? If it didn't change. So that's a point of inflection. So it's got to become stationary. So something like that or like this. And that's all we have. And then that's just that, and it's approaching an asymptote, which is fine. You'll see, it won't bother us. You'll see what it would do anyways. This one, back to this. Horizontal point inflections, what do they become? And intercepts. So they're not stationary up here or down there. Where are they specifically? Yeah, specifically on here. On the actual axis. They're right there. So you actually have their y values. We're done. Because we're going to start up here. We're going to start up here, right? Going to go down. What are you going to do? Hit this, come back up. And then I'm meant to have an intercept. For me to have an intercept, I've got to come back down, which means I've got to have another stationary point. That's really weird. And that's the other one that everyone misses. But you see what I did? I did it anyway, so if you miss it, I'm trying to show you what you would do. So I'm about to get the right answer. But what did we miss? Another stationary point, which means we must have missed what? What's before the stationary point? We must have missed the point. Look at this. So this is looking like it's sad. Looking like it's sad. Wait, yeah. Sad. Happy. Wait, what? What happened here? Sad. So there's a point of inflection there as well. But see how I did it? I purposely ignored it to show you that if you do miss these, it's okay. As long as you got those major ones, you'll see everything just works out. Anyways. Cool. I'll continue. Coming up, I've got to come back down to meet this guy. This guy's going to look like this, but I can't intercept. Why can't I do that? Why can't I cut through? Because what did this need? What did the black line need to have for me to have an intercept there?
Stationary point.
Good job. See, you guys are seeing this. If for this to just continue like this, there needed to be a stationary point here. There wasn't a stationary point. So what am I going to do? I'm going to do that. It's going to approach this asymptote. You can't do it this way. You can't draw that because that still looks like it's going to cut through. You can't draw it any other way. I don't know, whatever else you guys can think of. It just won't work. It has to approach this guy. So there's got to be another point of inflection there. But you're not worried about this stuff because that's not what you're getting taught. Even 4 year students don't do it that way. That's it. Finished. Full marks. That's the hardest question you're going to see. That's everything. Asymptotes and horizontal point of inflection. Then it's just a matter of you practicing. This black one, keep doing it. Don't get thousands of different questions. In this exact one, see if you can start it from the beginning and get the whole thing. And if you actually understand it yourself, teach it to your brothers, teach it to your sisters, teach it to your parents. See if they get it. We're done. Let's go back to this question. Wait, any questions at home before I move on? I'll save this document as well. Derivative graphs. Derivative set graphs. Done. All right. See now, the way I teach this, I say don't do double I, because you might not know what's happening to it. Do triple I first. Once you've got your triple I, you'll see what happens for your large values of x's. So now we're going to do our derivative graph. We're going to do triple I. Let's rub this out. Back to this question. And we're going to do triple I. All right. We know where we're going to start. Wait, let's write out ISP. We're going to go up. And we know that, I think the best one to start with is stationary points because you straight away know they're just intercepts. So there, yes, and there. And that's it at the moment. Yep. Points of inflections, let's see. The best thing maybe is just follow it from the beginning, right? Just go sad, 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 sad. Somewhere here, happy, 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 happy. Somewhere there, sad, 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 sad. True? So we've got a point of inflection there and another one there. Anyone see any other ones? Because I can't. Sad, happy, sad. Yep, I'm pretty happy with that. All good? What do my points of inflections become? Stationary. There you go. Again, we don't know the y values. That's all you know. The other thing you know is we're going to start top left. Here we go. Starting top left, the first thing you've got here is to cut through this guy. You're going to cut through. What's going to happen eventually? Are you going to come back all the way up here and do it, make a stationary point? No, of course not. That looks weird. How can you have an intercept? You didn't have an intercept here. So just keep following, go down, go down, go down. There's an intercept. And you can see, everyone asks me, how far down do we go? Doesn't matter. Right? There is no y values. So I'm going to continue anyways. That, and I think you guys can see, but we have the same problem. What do? Just draw an arrow at the end? No, because that looks like it's going to do this. You have another intercept, which you didn't have. How are you going to shape it? Approach the asymptote. I'll pause there. That's triple I done, and obviously double I is done, because what happens to y dash for large values of x? What's happening to the derivative? What's it approaching? For large values of x, what is y?
equals 0.
Yeah, y dash. Y dash meaning the y value. What's happened to the y value? It's approaching 0. X is approaching infinity. Y is approaching. True? When we say f of x, we say y values. When we say f dash, it's also y values. So yeah, f dash of x is approaching. See how quick I did double I? Don't do double I before triple I. Always do triple I for these questions before double I. Done? I'm happy, if you're happy. Everyone, all good? That's a HEC question worth 4 marks. There you go. The only one that's harder than that, as I said, was the horizontal point of inflection. Because like, there's only a very small few students that really know that horizontals become both stationary and intercepts. So expect that. All right, very good. Now all the fun stuff, easy. We're going to smash through these. We did this last lesson of last term for those who were here. So these ones are going to be nice and straightforward. This is worth about 8 marks in your HSC. So the guys that are going in their exam, not next week, week after, they pretty much are expecting this to be about 8 marks. How do we find stationary points?
Y dash equals 0.
Equals 0. What does greater than mean? Increasing. No, you're mixing up y double dash. Okay. Stationary points? Increasing y dash greater than 0, decreasing y dash less than 0. Good. Find the stationary points, y dash equals 0. Let's go. Bang, 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 bang. Equals 0. Back to baby stuff. X equals 0. X equals 2. It is a point. What are you meant to usually have with a point? An x value and a y value, coordinates. Sub it back into the original. Y equals 0 and 0 is 0. Y equals 8. Take away 2 squared is 4. 4 times 3 is 12. 8 take away 12 is negative 4. Therefore, your points are obviously 0, 0, and 2 and negative 4. Yes? Any questions? Brad, Chen, easy? Am I going too fast? All right. Stat points. Y dash equals 0. 4x cubed minus 16x equals 0. Factorize 4x out. X squared minus 4 equals 0. And then obviously you get x equals 0 and x equals, say it again.
Plus minus 2.
Yes, like that. I like that. 2 and negative 2. Let's just separate them. And then sub back in. 0, y equals 2 to the power 4 minus 8 times 4. Negative 16. And this should also be negative 16. So really, this one, no students really get it wrong because of knowledge. It's just silly mistakes. Maybe they forget the plus minus to whatever. Okay, done. We'll just leave that one for whatever. It's nothing. 3x squared equals 0. X equals 0. Sub back in. Y equals 0. Which we already know, right? Because we understand from a cubic. I did say it's a horizontal point of inflection, which means it has to be stationary, because horizontal anyways, and it's a point of inflection. That's a horizontal point of inflection. But there it is. Easy. The question now arises, what type of stationary points do we have? we actually don't have 2 possibilities, we have 4 possibilities. Maximum, minimums, and horizontal points of inflections, depending on which way they're shaped. All of these guys call it stationary points of inflections, but I call it horizontal points of inflections. Why? Because they're both horizontal, which means they're flat, and they're also point of inflection, so they're moving from a sad to a happy. See? Okay. All good. Consider the following diagram. I think we already did this. Consider the gradients from D to B to complete the table. It's okay. Let's just get to this. Nature. Find the stationary points and determine its nature. Sketch this function. All right. I'll give you guys 2 minutes to just do the stationary point bit, and then I will do the nature, and I will sketch. All right, let's do it. Y dash equals 3x squared, take away 3, equals 0. So therefore, x squared equals 1, and obviously x equals plus minus 1. Sub it in, y equals 1 take away 3, and y equals -1 plus 3, which is 2. Any questions? Don't make me go too fast and then talk to me. Slow me down if it's too much. Alessandro, where did you go wrong?
Oh no. Something in.
Subbing it in.
Yeah.
Okay. Nature. There was 2 methods. Eden, Tiana, what do you guys remember? Y dash table, yep, or
Y double dash method.
Y double dash method. We got it. We're going to do both. So nature. Not bad for one lesson. Y dash table. So you only do it one way. For the boys who weren't here, you only pick one, right? But I'm going to keep doing 2 just so you guys get used to this. There's 2 methods. Method 1. Y dash table. All that means is you will have I believe so. I hope so too. 1 and -2, -1 and 2. So at Y dash table, you choose one number before, one number after. One number before, one number after. Yes? Remember this? Just a quick point with these numbers, you want it to be as close as it can be to this number. Because sometimes if you're going too far, so let's just say if instead of choosing 0, if I chose -1, it actually would be wrong. It wouldn't work out. So if you ever see that these numbers are pretty close, then choose an even closer number here, like 0.9 and 1.1. Then you won't go wrong. So you want them to be as close as possible. Okay, and then we're just going to sub it back into our Y dash. That's why it's a y dash table. So sub these numbers into here. So 0, take away 3, negative 3. Sub 2 into here, 9. Sub negative 2 into there, should still be 9. Sub in 0 will be negative 3. Cool. And what did you guys just learn at the beginning of the lesson? We said when y dash is less than 0, how does it look in terms of its slope? Decreasing, so slope to the left. What about when y dash is equal to 0? Oh, what did I write here? Negative 2, as if y dash is 0 here, you guys. Right? It's y dash. That's a y value. I made the most rookie mistake. Very bad. Y dash is 0. Y dash is 0 at 1. Y is negative 2. Y dash is 0. That's what you just found. Y dash is 0. So 0, and then y dash is positive. Don't worry about the number. Positive. So how does that look? Boom. And then same thing here. Y dash is positive, 0, negative. Yes? 100%. You guys are home? Yes? That's a max. That's a min.
So is that like the nature? Is that how you draw it?
That is exactly the nature, and that's pretty much how we're going to draw it. Yes. So like it's trying to say at 1 and negative 2, at this point, it needs to be a minimum turning point. But at this point, it's got to be a maximum turning point. Yeah? That's method 1. Let's quickly look at method 2 as well. Method 2 is y double dash. If y double dash is greater than 0, we would say it's a min straight away. If y double dash is less than 0, we say it's a max. Yeah. So y double dash. Y double dash equals from the top 6x, and then all you do is at your point that you've got, so 1 and negative 2, at 1 and negative 2, y double dash is 6 times x, which is 6, that's greater than 0, which we know is a min. At negative 1 and 2, y double dash equals 6 times x, which is negative 1, which is negative 6, that's less than 0, and that's a max. There's less substitution, as you can see, less fiddling around. I'm going to say 8 out of 10 times you should do method 2. 2 out of 10 times you shouldn't do method 2. You actually should do method 1. So you need to know both. You'll know when to do when. So always go for method 2. If you realize the derivative is hard, that's when you'll know, oh yeah, maybe I should have just kept with method 1. Right now, because we haven't even started derivatives of like trig and logs and stuff, when we do that, it might get a little bit harder to differentiate a second time. It's just going to be time wasting for nothing. You might as well have just gone and subbed it in. Sometimes. You'll see. The max min problems.
Yeah.
Those are the ones that you're going to realize questions get a bit tough. Oh, good. Chan, any other questions at this point?
No, not really.
All right, and then we're just going to sketch it now. To sketch this, we know the intercepts are at 0 and 0. We might as well see that. So why not? That's right there. I've got a minimum at 1 and negative 2. At 1 and negative 2. Right there. Minimum. And at negative 1 and 2. Negative 1 and 2. Right there. I think we all can see what graph it is. That's a max. That's a min. Connect the dots. Done. How many marks in your exam? This one here, 2, 4, 6. 2 marks for stationery, 2 marks for nature, 2 marks for writing your name. Sketching the graph. Easy. Easy, easy, easy. Seriously, you guys cannot come back to me and say I did that in this one. Cannot. I won't accept it. All right. Done. Move on. Anyone still writing at home? I'll send you this booklet once we're done. The updated version, I guess. Okay. Find the stationary points and determine their nature again. All right. I'll leave it with you. Go. Don't rush it, right? We're just working for marks right now. Accuracy is all we want. Don't rush it. Don't make mistakes. Look over your work again. Use your calculator. What? 25? How good is that? Felt like it was already 2 hours. That's good. Maybe am I going too fast? Chan, Rad, am I going too fast, you guys?
I'm at the terminal nature bit.
Yeah, but I'm saying, am I going too fast? Like, do you understand all this so far?
Yeah.
Wow. Okay, all good. Feels a bit fast, right? I guess the homework we'll find out.
Exams come back from really.
Not really, because now in 12, everything is as you see it. Not like year 11. What is it? And you're sketching it. Yeah, sketch it as well. Did you guys do both methods for your nature, or are you just going to stick to the one? With white dash table for you? What about you? White double dash for sure? White, same? All right. Anyone want me to do white dash method then? If not, I will probably do white double dash as well. If no one says anything for nature. So far, it's right, what I've written. So everyone's happy with the second method then? We'll just stick to that for now. Nature, y double dash. All right, here we go. Y double dash, so at 0, 0, y double dash equals equals 0. We'll come back to that in a second. Those who were here last term probably remember it. At 2 and negative 64, y double dash equals Looks like it's positive. Yeah? 240. Greater than 0 is a min. At negative 2, positive 64, y double dash equals, I'm going to assume it's a max. Yeah, negative 240, less than 0, it's a max. Okay, the one at 0 is what we call possible point of inflection, because points of inflections are where we do y double dash equals 0. The reason why we use the word possible is because that's the third thing we're meant to be doing. You can't actually conclude it in the second part yet. So that's the first part, stationary points. Second part, nature. Third part, it's meant to be points of inflection. So at this point, we can only say it's possible point of inflection. But because we haven't technically done points of inflections, I'm not going to introduce it yet. For this one here, I am going to do the y dash table. Cool. Because I believe it's not a point of inflection. So it probably will fail the point of inflection test. We're just going to do the y dash table and see if we can get it out. That's 0, and that's negative 1, and that's positive 1. Sub in negative 1 into the original, I get 15, take away 60, which is a negative, and at 1, it's also negative. Actually, I was wrong. It is going to be a point of inflection. So you can see that, you see how it became both negative? So what does that mean? Look, negative, 0, negative. Horizontal point of inflection. Right? But you can't say that yet until you do the third bit. So for now, that's all we're going to conclude. It's a horizontal point of inflection, but I'm going to show you what we've got to do with the third step. Yeah, negative, 0, negative. All right, let's see. At 2, it's negative 64, which is a minimum. At negative 2 and 64, it's a maximum. And then we've got a horizontal point of inflection at 0, 0. There we go. And so what just happened here? You can see it's almost the same, right? And as it should be, as it really should be. Cool. Second derivative. Let's start that. Ready? That's a good graph. That's a good graph. Second derivative. Well, you guys just did it. So find the second derivative, you just got to differentiate twice. And then, example 8. If you want to read your notes, you can. But example 8, find all stationary points and determine their nature using the second derivative method where possible. So example 7 and example 8. Easy. All right, we've got here. Okay.
Yeah, I love this and something else.
Okay, let's do it. Second derivative of this, y dash equals 12x cubed minus 6x squared plus 3, and then y double dash is 36x squared minus 12x. This one, if y is this, find all stationary points and determine their nature. Y dash is 3 minus 3x squared, y double dash equals negative 6x. Learn to underline like I do, stat points, and then I write y dash equals 0. It looks neat, because imagine in your exam, it's going to be a whole book of just writing everything. You want to keep things neat. So when you're coming up to sketching your graph, you can identify your points easily. Stat points, make this equal to 0. I think we can already see x equals 1 and x equals negative 1. So back into the original. Y equals to 3, take away 1 is 2, minus 3 plus 1, minus 2. Thank you. Nature. Y double dash. At 1 and 2, y double dash equals negative 6, less than 0, which is a max. It's the opposite, isn't it? Because less than 0, you would usually think it's min, but it's max, it's opposite. So, and then at negative 1 and negative 2, y double dash is equal to positive 6, greater than 0, min. And another one. Example 9. When you're done. It's just practice, 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 practice now.
Still stationary.
Correct. And confusion. Example 9. Any questions, Mike? All right, the sums of let's see. Did you do it through the y dash table this time?
Yeah.
Just mixing and matching?
No, there's no way. Because it's possible.
Okay, fair enough. Good. F dash of x equals 4x cubed. Yeah, I see what you're saying. F double dash x equals 12x squared. Stat points. Obviously, only when x equals 0. You sub it back in, you'll get y equals -2. Sub back into the original. Yes? Dana? 0 take away 2.
Yeah.
And then when you do your nature, using your y double dash, you're going to get a times 0, which equals 0. So all you can conclude at this point is possible point of inflection. So then if you do it through the y dash table though, x, y dash, there is 0, there's 1 before it, there's 1 after it, that's always 0 at y dash. At -1, you sub it in, it's -4. A +1, you sub it in, it's actually +4. It's not a point of inflection. So if we had gone and done points of inflections, when we're about to start it soon, you would have realized it would have failed that test. So it actually isn't a point of inflection. So this is a -0 positive. So it's actually not a point of inflection, therefore it is a min. It's actually a minimum. Did you realize it was a min?
And means of like that, so that's what's
Yes, because that's why we're using the word possible. Because it could work, it could not work. It doesn't mean that it's always going to work. Most of the times it does work. But because it's only most, I can't actually say just do that. I've got to tell you, you've got to do both. The second derivative can be useful to determine the concavity of a function, which is now, I think we've explained it a few times, a point of inflection is where the concavity of a function changes. In other words, the graph changes from going upwards to going downward, or happy to sad. Another way to think about the point of inflection is a point where the tangent crosses the curve. That's like the worst definition, but anyways. Determine the points of inflections on the following curve. All right, so I guess anyone, you can just tell me to stop if you want. Yep, one's there. Yep, pretty much. Look, it doesn't matter if you went, just because it's obviously a sketch, it doesn't matter if you went there, but it's somewhere there. Yep. Interesting. So you reckon there's no more?
No.
But there has to be more, because if we follow the whole happy sad thing, this is sad, 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 sad. Happy, 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 happy. Well, right there, you said happy, and you're saying it's changing. Sad, 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 sad. Right there, it's changing. Look at it. It's facing this way now. So right there, it's actually changing. Isn't it? Is that what you were thinking, Tiana?
Yeah.
Right there? All right. That's also a point of inflection. One more time. Sad, 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 sad. Happy, 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 sad, 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 sad. Happy, 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 happy. All right. All right, the point where the tangent crosses the curve indicates a change in concavity. A curve can be concave up or down. It is inefficient to determine the gradient at every single point to see when so we need another way of doing this, and that is called, to find an inflection point, we let y double dash equal to 0. So we find a stationary point, y dash equals to 0. How do we show something's increasing? Y dash is greater than 0. How do we show something's decreasing? Y dash less than 0. How do we show point of inflection? Y double dash equals to 0. How do we show something's concave down? Which means it is a maximum. Y double dash less than 0. How do we show something's concave up? Or a min? Y double dash greater than 0. So don't mix up minimums and maximums with y dash. It's y double dash. Cool. Show that 0, 0 is an inflection point. I guess I'll do that one. Y dash is 3 minus 3x squared. Y double dash equals negative 6x. Points of inflection, how do we do it? Y double dash equals 0, and then sub it back in, and you'll get x is 0 and 0. Easy. Did this easy, or it was just for something else?
No, it's
Okay,
stretch.
stretching. Yep, done. All right. Find all critical points. What does that mean?
Everything.
So can you tell me everything?
Point of intersection.
Point of inflection. Oh, wait, intercept?
Intercept.
Yes, I thought you would miss that. All right, point of inflections, stationary points, and intercepts. Now, when we talk about intercepts, it's generally more the x-intercept, the y-intercept. The x-intercepts are not generally easy. This one it is. So this one we're going to do both x and y-intercepts. But generally it's more about the y-intercepts. Good luck. So you got to find x and y-intercepts, stationary points, and points of inflection. Everything. Just take your time. Take your time. Actually, don't do points of inflection. So start with intercepts, do the stationary points. I will do the point of inflection because I want to talk about something. So. Do you have any questions now? Okay, my turn. Let's see how far you guys got with this. Find all critical points. Okay. Y dash equals 3, sorry. I'll start with intercepts, just because I think that's what you guys started with. Yeah, fine. When x equals 0, y equals 0. When y equals to 0, it'll look something like this. You would have to factorize it out. And then you'll get x equals 0, and I think that looks like a perfect square. So I think you'll get x equals -3. You got that? Did you get that? For your intercepts.
Insert?
Oh, you haven't done intercepts yet?
No.
You've just done stationary points?
Yeah.
Fair enough. So intercepts we now know are there. Intercepts. All right. Now we're going to do stationary points. Y dash equals 0. Y dash equals 3x squared plus 12x plus 9 equals 0. Divide everything by 3. X plus 3, x plus 1, x equals -3, x equals -1. Yes? We already know if we sub in -3, didn't we just say that it's an intercept? So we already know that y equals to 0 there, but I'm sure if you sub it in, you'll still get y equals to 0. And then this one here, y equals to, anyone done it yet? 24. 24, when it's -1. -1 plus 6, -9. -10 plus 6, -4.
It's the original.
Original has to be the original because that's your y. Y, it's okay. Because there's a lot. There's y dash,
Yeah.
y. Good. Stationary points. Okay. Then we have to do nature. Y double dash. Yeah, or less than. That's the one. You're not meant to do y double dash method. So we do y double dash for this, which is equal to 6x plus 12. So then you go at -3 and 0. What does y double dash equal to? 6 times -3, which is -18, plus 12 is like something like this, which is less than 0. All you care about is concavity, so max. You don't really care about the number. You don't care if it's -50 million. The negative is what is important to you. At -1 and -4, 6 times -1 plus 12, I think that becomes a positive, which is a minimum. Happy? Then we do points of inflections now. And I said, that's me. All right. I've got to just fit it here. I'll do it in black. All right, something new. Here we go. Point of inflection. Y double dash equals 0. Please look at my working out. It's going to be done exactly the same way. I want to see it. Stat points, underlined, y dash equals 0. So that means for the rest of your life, you'll know stationary points, y dash equals 0. You'll be able to teach it to your kids. Stationary points, y dash equals 0. I'm going to move on. Point of inflection, y double dash equals 0. Let's do it. So this bit here, 6x plus 12 equals 0. X equals -12 on 6, -2. Sub it back into original, because that's where you get y value from. So sub it back into the original. -8 plus 6, -2 squared plus 9, -2 is -2. So now we found our point inflection. Here's a big but. That's right. But with these guys, with points of inflections, you must prove it. You must prove it. So all you've done is just some math. You just differentiated something. I mean, you can differentiate a third time if you want, or a fourth time. So what? You just made it equal to 0. So with point of inflections, unfortunately, you have to prove it. Every year, I've still had one student that slips through the crack and forgets to prove it. Even if the question just says, just find point of inflection. Don't just stop at that. You have to prove it, because it's not a point of inflection until you prove it. How do we prove it? Y double dash table. So we had the Y dash table before, now we've got the Y double dash table. All we're trying to show is that these numbers here and here are going to change. That we don't care about the order. It's not like the other one, right? It's not like this one. Let me just show you. It's not like this one where the order mattered if it was negative and positive, or positive and then negative. Order doesn't matter. All we care about is that there is going to be a difference, and if there's going to be a difference, that means it's moving from a minimum to a maximum, or a maximum to a minimum, whatever, which means this actually is a point of inflection. All right, so x is -2. Y double dash is what? When x is -2. Always the middle term has to be 0. Choose something before it. Don't choose -3. Because that's a stationary point. Don't do that. Right? But we'll go with 2.5 and we'll go with -1.5. Good. So sub it into Y double dash. 6 bracket -2.5 plus 12. Still -3, and I'm going to assume the other one's going to give me a +3. And all you got to say now, you have to say this, since change in concavity, wait, before I continue, why is that a concavity? What do we know about Y double dash being less than 0, Tiana? Y double dash being less than 0. That's a max. This one is a, so something had to happen between them for it to move from a maximum to a minimum. Oh yeah, a point of inflection occurred. Cool. So since changing concavity, -2 is a point of inflection. We're done. That's amazing. Finished. That's very, very good. That, again, you're looking at 2, 4, 6, 8. Yeah.
So there is a symmetrical kind of intercept.
Yeah, because you got your x-intercepts and you got your y-intercepts. You have to factorize. Does that make sense? You have to factorize the x out. So that's why. I've done it really quick, but like, you know, yeah. Usually it's done a bit slower. But yeah, 2 marks, 2 marks, 2 marks, 2 marks. Good. All right. Let me just see what else is left. All right, I think I'd rather do this. We'll leave that on for homework because I'm kind of tired of it, doing the same thing. I think you might be as well. So just do it again. We're just going to change the question. We'll just go this. Sketch this showing everything, right? So sketch this, finding everything. So literally what we just did above. He's got to sketch it now. Sketch that, finding everything. Intercepts, start points, if there are any. If there isn't, don't worry about it too much. But start points and then points of inflections. Okay. All right, this one. For what values of x is y concave up? So what's the key word there now? Yeah, the fact that it's concave up. So the concave up means it's a min, which means y double dash is greater than 0. There we go. So now you know how you're meant to start. Y dash 9x squared minus 8x plus 5. Y double dash 18x minus 8. And then what are you going to do, Lysandra, at this stage?
Equal to 0.
Yeah, pretty much, but essentially greater than 0. Because it's not squared or anything, you can just, I think you can get away with greater than 0. Greater than 8. As long as x is bigger than 8 on 18, it's always going to be concave up. Which essentially means, what? Doesn't it mean that at 8 on 18, it's the point of inflection?
Yeah, because from something else
To that, for it to always be concave up. But you said equals to 0, and when y double dash is equal to 0, you would have just solved for 8 on 18 anyways. All good. Done. All right. All right. Let's see. How are we going for time?
Isn't it when you're
So,
dividing on your chlorine, you change the sign?
when you divide by negative,
You need to-
yeah, it's divide by negative, not divide by just any number. All right. I think we should look at example 15. Let me have a quick look at it first. 6 marks, which means 1 mark each. Yeah. Just read it. Just read it, maybe answer a few of them. If you've got an answer for one, shout it out. Just say, this is my answer for I. Don't overthink it. Don't look at it weirdly. Just Dylan.
We just started with like medium, vertical.
Alexandra, why is here? And to be right. Trust me, you do. Anyone? Evaluate f of 0. What does that mean? Seriously, don't overthink this. Subbing 0 for x, which means, but when x is 0, what does it also mean? No. Don't mix them up, you've got to be careful. Which is 6. F of 0 is the y-intercept. Right, where x equals 0. I like that he said that, but he didn't link it together. Y-intercept, 6, done. So, where is the y value greater than 0? When here is the y value greater than 0? No, look at it, don't just make up stuff, hold on. Y value, look at this Y value. When is it greater than 0? Seriously, have a look at now your x-axis.
Less than, sorry. That's it.
Super close. X is, can you give it one last time?
Less than, okay.
Less than 10. It is equal to 0 here. Don't do what you did at the beginning. I know what you did at the beginning. You just said, what were you going to say? Like, I don't know, Max, you know, I don't know what you were going to say at the beginning. Like, don't do that. Just, yeah. Like, think about it. Like, where is the Y value going to 0? Just take a step back. Can you agree with that? Do you? Can you see it? The Y values are all positive here. So, X is less than 10. Mark a point A on the curve where Y dash is equal to 0 and Y double dash is less than 0. What does that mean? What does Y dash equal to 0 mean? Y, step at a time. Y dash equal to 0. Y dash, stationary point. What does Y double dash less than 0 mean? So, pretty much mark A where there is a maximum. What? Maximum, which is where? I think 12. Oh, yeah, that one. Yep. A at 6 or at 4.5 or 5, whatever. Good? Looks weird, right, when you're reading them like that, but it's actually easy. Just write down what you know. Write down SP. Write down max. Next one. Mark a point B on the curve where Y dash and Y double dash, look how I'm reading it. I'm not reading it F dash, don't complicate it. Y dash and Y double dash have opposite signs. Opposite. Don't say it, man. What does it mean? I'm going to ask you the same question. What does it mean? Have opposite signs. Thank you very much. Opposite signs. Just make sure one's positive, one's negative. One's positive, one is negative. If that didn't work out, then it's the other way around. One's negative, the other one is positive. Okay, what does it mean about Y dash positive? Y dash positive. What's the word I'm looking for?
Increasing.
Increasing. Y dash negative. What's the word I'm looking for?
Maximum.
We're looking for something that is increasing and it's a maximum. Let's have a look. Here's your max. Can you see this is a max? And can you see right here it's increasing? I'm just going to put right there B. If you did it the other way around, it would still work. It would have been a minimum and decreasing, which is right there. Minimum, decreasing. So that could have also been B, for example. So that's why they didn't care if it's as long as it's an opposite sign. Okay, all good. V. C is a point on the curve where the concavity changes from concave down to concave up. Concave down to concave up. That means point of inflection. Mark the point C. Where is it concave down to concave up? Right there. Let's have a look. That is concave up. That is concave down. And that is concave up again. So I think right there, it is changing concavity right there from a sad to a happy.
When there be 2?
What do you mean 2?
6 and 0. Or 0, 6.
Where's 0?
0 because the x-axis is 0.
This one here?
Yeah.
This is changing from a happy to a sad. Right?
Yeah.
Other way around.
Yeah.
Without something like that, yeah, there would be. You're right. VI. Can I leave it with you guys? Which of the following is true at the point C? Well, I think we've already spoken about that. Which one's true? is y double dash less than 0, equal to 0, or greater than 0? Yeah, of course, you guys just said it's a point of inflection, right? Well, that was easy. Write it off. 6 marks. It's just a bit different, but what do you have to say? I don't know. Try example 16. The diagram shows the derivative of the graph. Integral y equals f of x. I don't want to do integrals today. All right, now this is, I'm going to write, what's the date today? 15th. So we're going to write 22nd of October. That's for me next week. I'm not going to do it today. I'll just confuse you. Example 17. Yeah, I like it. 1 mark each. Yep, that's literally what we just did. Go. Take your time. No point of rushing it. How much marks in the exam? 4, 7, 9 marks. Okay. There we go. All right, let me have a look. Write a letter which names a point on the graph for which, see, again, it looks like a lot, like it's weird. Don't do it that way. Write some things down that you know. This, I know stationary point, and this one I know max. I want a max stationary point, which looks like C. This one, stationary point and point of inflection. That's a horizontal point of inflection, right? Because if it's stationary, which is horizontal, and it's a point of inflection, it's a horizontal point of inflection, which looks like E. Good job. Seriously, that's amazing. Y dash less than 0, that is decreasing, and this one is a minimum. So look at my minimum, that's my minimum. I want this bit here, decreasing. So I'm going to use it, this one here. Oh, it's not A, it is D. It's not A. A is what specifically? A stationary point. It's a minimum stationary point. It's actually D. The sneaky guys.
Oh, I
Can you see it?
Yeah.
It's a minimum, right? And it's decreasing. Yeah. There's always going to be one sneaky one, doesn't there? Has to be one. This one, increasing, and it's, oh, what does this mean? The graph is greater than 0. So graph above x-axis, pretty much. So increasing, that's decreasing, and I think it's this one. That's increasing, it's above, yep, B. So A is just a trick question there. Write down the set of values for which f of x is an increasing function. So when is it an increasing function? 3 marks. So probably there's going to be maybe 3. But let's see. Decreasing, increasing, 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 0, decreasing, 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 decreasing. Okay. So from -2 to 3, not including 2 and not including 3. For what values, plural, that's how you know there's like a lot of numbers, whatever. For what values of x is the curve concave up? Again, concave up meaning this thing. It's concave up. Okay. Sorry? Tell me.
14 on 3.
14 on 3. Where's your 14?
Negative 14 on 3.
Where's negative 14?
That way. Negative 14 on 3.
Well, how'd you get negative 14?
Because it's like mirror image, because concave up, rubber.
Overkill. No, what are you doing? No. You don't need to know, you don't need to mirror the image, nothing like that. Any ideas? You? Tell me. No? Eden, any ideas?
-2.
-2. -2 is specifically stationary. Like, it's not just concave up. It is concave up there, but it's not, it's stationary. Like, this is still concave up. This is still concave. Yeah. What stops your concavity from being concave up? What? Point of inflection. So where's your point of inflection? Somewhere here. At 2/3. 2/3. Yeah. So it is concave up when x is less than 2/3. Yeah. So I mean you overkilled it. X is less than 2/3, concave up. Now, concave down, hold on. What about here? Also concave up, isn't it? From 5 to 5 less than x, less than 8. Concave up. X less than 2/3, 5 less than x. less than 8. All right, I might just write continue next week. We're good. I just want to explain what homework is and everything so we all know.